Hi, I'm Andrew Doyle. I'm going to talk a bit about the EMBERS system, which is a system we built to automate the processing of open source data. So this was built for the IARPA Open Source Indicators program, and we developed this over the past 3 years, and it ran as an operational system. The Open Source Indicators program was trying to see what information you could get out of social media. Was there any information in open sources that could relate to predicting socially significant events? And the program manager, Jason Matheny, who started this, wanted to do it as a competition. We were one of the teams. We were a consortium of universities with a few industry partners. I'm a member of CACI. We integrated and operated the system, and it ran 24/7 as a system, delivering automated predictions, such as this. We did not predict broad trends. We predicted specific events. On a day, a group of people in a specific place will protest. There will be this much flu occurring in a certain country this year. So these are very specific, detailed events, and we were scored against ground truth. Analysts went through, read the newspaper, looked at the health data, for example, and gave us essentially a A through F score. We got about a B in terms of the quality of our predictions. We did pretty good in terms of being able to predict about a little over a week ahead. The system took in data from many sources. We had Twitter, Facebook, curated sources like HealthMap, derived sources like Google Flu Trends, pulled all that together into a number of models and distilled that down into a set of predictions which were automatically delivered. No human in the loop. This was a purely streaming architecture. We did not have a central data store. We did not have a set of MapReduce jobs that ran. We processed the data as it came in through this pipeline: ingest, enrichment, modeling, and then a fusion and selection element at the end. Ingest, we would simply have APIs that went out to the internet, picked up data sources, RSS feeds, Twitter, what have you, normalize that into JSON messages, add some identifiers so we could track it. We have traceability through the entire system, and add some key metadata, and then we could process it. This is a rough look at the volume of data. If you look at the number of messages, unsurprisingly, Twitter is a big chunk of that. If you look at the actual volume of bytes, the content, the textual content, the actual things pulled from Twitter, URLs in Twitter, represent a large amount of that data, a much larger chunk. We did a number of processes to do textual enrichment. It was largely a text-based system, and so we did base linguistics, some date normalization. We did a couple different approaches to geotagging, depending on the type of the text, sentiment analysis, and then a key phrase matching. Our geospatial interpretation was a fuzzy rule-based system for large text, and then we had a classifier for short text like tweets. Entity extraction was off the shelf from Basis Technologies. We used a date normalization to find dates in text. This was all an ensemble approach. It was not a model. There were multiple models that dealt with different pieces of the data. Multiple models would deal with the same data or different data, and then it was fused at the end, which was its own model to look at what we thought the best predictions would be. So some of the models, the baseline model is actually very interesting from an analysis standpoint because it tells you what's not interesting. It tells you what happens routinely. We could look at events that were planned, where people would simply say something. We also had a geo-temporal clustering model, and some others. And then quickly, this is a look at how we did on some protests in Venezuela in 2014. Remember, these are predictions. So that green line of what we sent before it happened. So may not have got the volume exactly right, but we did track the graph roughly. So that's the overview. has all the great big data buzzwords: big data, predictive analytics, streaming architecture. If you're interested in details, please come down and ask me questions. I'll be at the CACI booth on the show floor. Thank you very much for your time.